Hi everybody, how's it going? Welcome to Kubernetes Happy Hour. This is the third month we've been doing this. Super excited to talk to you today about a topic that I'm really into. It's CRDs. So CRDs are custom resource definitions in Kubernetes. This is the one thing that really made me realize the power of Kubernetes. So CRDs used to be called third-party resources in Kubernetes, and I believe in version 1.7 it switched over to custom resource definitions. So we had some work to do to switch over from third-party resources to custom resource definitions. And we're using them today in our Kubernetes cluster. So let me take a step back and talk to you about what a CRD is. So it's a custom resource definition. Basically what it is a way to represent an object in the YAML file and have it be discovered behind the Kubernetes API. So what's powering the Kubernetes API is something called etcd. So etcd version 3 in particular lets you list out resources. It lets you, well, the API that is, lets you issue gets against the resource, issue deletes against the resource, puts and posts in a RESTful style. This is all REST kind of infrastructure. And also lets you do something called a watch. So the power of this is really the watch. So what a CRD is I can go and define my own kind of object. And when I define that object, I can go stick it behind the Kubernetes API. Inside that object, I have my metadata about my object, all my attributes and all my values. I stick that up into the Kubernetes API, which is powered by etcd. So the backend store for that is etcd. If you're using a more recent version of Kubernetes, the etcd version is going to be etcd V3. If you started up your cluster several versions ago, your etcd cluster is probably at etcd V2. It's preferable to be etcd V3 versus etcd V2, and I'll get into that in a little bit, what the big difference is between etcd V2 and etcd V3. So, okay, so you have these things that are behind the Kubernetes API. So it lets you essentially get at them through either a browser if you wanted to. You could get at them through a programming interface like a command line tool. You get at them through the Kubernetes client. And what I'm going to do is I'm going to step through the whole process of creating a CRD from scratch. We'll go over the spec. We'll go over each and every element inside there, and we'll go over what it means. We'll create an instance of our CRD, and we'll go in and we'll change the instance to show you how to set up the data inside your CRD and what happens when you change the values inside your CRD. And then we'll write a simple controller on the side, written in PHP, actually in Python. And what we'll do is we'll watch for changes to our CRD, and I'll show you the power of this. So what this means is, so our data is being persisted by etcd. And now on top of it, we have this powerful utility called watch. So what this allows us to do is to be notified in real time when changes happen to our data. So if I go in and I decide to change a CRD for any reason, let's say I want to change the parameter of my favorite football team from the 49ers to the Giants, right? And I can programmatically go out there and create applications that are listening for changes to my favorite football team. So in real time, my applications get notified that this change has happened, and can take appropriate action, like either tell me I'm crazy, I don't know what I'm talking about, the Giants are the worst team ever, or tell me, yeah, the Giants are the best team ever, and congratulations for being a Giants fan. So that's just one example of a CRD. So there's some applications out there that you may be familiar with that use CRDs. One of them is the Prometheus Operator. So we use a Prometheus Operator here. And how Prometheus Operator uses CRDs, it uses them something called a service monitor, which allows you to be able to monitor different services in different ways. And there's a Prometheus itself CRD, and there's an alert manager CRD. So Prometheus CRD is a way to tell Prometheus Operator how to set up your Prometheus instance. And the alert manager is how to set up your alert manager instance. We also use CRDs for sealed secrets. So sealed secrets, Bitnami sealed secrets, or CRD. So that essentially means when you go and create your Bitnami sealed secret and you make changes to it, there's a controller out there that's listening for changes to these CRDs, and it is either encrypting or decrypting your sealed secrets based upon the changes that were made. So we use them all over the place. They're really powerful, and I think there's some use cases. One thing I want to touch upon is one use case I know about, which is really cool, is something called DEX. So DEX is the CoreOS IDP provider. So when DEX gives out client tokens, either ID tokens or OAuth2 tokens, access tokens to their clients, it persists them as a CRD. It does use its own etcd cluster. It doesn't reuse the, actually it does reuse the Kubernetes cluster. So it persists them in the Kubernetes cluster. And basically what that gives you the ability to do is to write applications to listen for changes to that identity token. So in real time, you can have applications that will go out there and notify either clients, browsers, or whatever it is, devices, that the token is changed or token's been revoked or there's a new token or something's happened. And then the appropriate action can happen. So what this means is your data is alive. Your data is not sitting there stale or static. So when you make changes to it, you have applications that are listening for the changes. So it's almost like your applications are now right there, being notified in real time when when data is being changed inside the CRD. It's a really powerful mechanism when you consider like geographical issues that people have and replication and whatnot, because now you're actually handling that through the watch kind of paradigm. And the watch paradigm, again, is enabled by etcd being the backend store, because etcd has this utility that allows you to be able to watch for changes to the data that's actually inside etcd. Etcd v3. So why is that important, etcd v3 versus v2? So etcd v3 introduced HTTP2 as the support for the watch command. So what that means is that you can have one connection to the etcd cluster listening for multiple things. Before that, you had to have an array of connections, one connection for everything you wanted to listen to on the etcd backend. So if you had etcd v2 and you wanted to listen to multiple changes, multiple resources, you had to create n different connections to the etcd backend. With etcd v3, you only need one. So what that means is that I can look for, theoretically, unlimited changes to the etcd v3 backend through one connection from my application. So that's a really useful, efficient paradigm. And also etcd v3 uses gRPC as a default mechanism for communications between the client and the backend store. So what that means is gRPC is obviously binary, so it's faster. But the big one is HTTP2. So you can have multiple connections get shrunk down to one connection, and you're listening for changes for your data that's in the etcd cluster in real time. So etcd cluster, again, is what powers Kubernetes. The etcd, if you have a most recent version, it's etcd v3. If you have an older version, it's probably etcd v2. You should come up with a migration plan to move to etcd v3. We're in the process right now of moving to etcd v3 ourselves, and it's a challenge because we use a tool called COPS, and COPS currently doesn't have an upgrade path that's fully supported to migrate from etcd v2 to etcd v3. Okay, so let's hop into it. That's enough of a background, I think. I think a picture is worth 1,000 words, so I can show you guys how to actually go into your Kubernetes cluster and make your own CRD. So to do that, I'm going to switch over to my console. Okay, I'm going to go to my console. Here it is. There it is. Okay, so this is my console. So I was playing around with this last night. I wrote a little program to do a watch, and you'll see that in a little bit. So let's go through this. Let me increase the font here so you guys can see this a little bit better. Okay, so what we got here in my current directory. So I had this thing called a fan. So I had this the CRD called a fan. So a CRD, the definition of a CRD is YAML file, right? So whenever I want to make a new kind of object, it's called a custom resource definition, or CRD. So the first line here is called the kind. So this is the custom resource definition. And again, this was introduced in Kubernetes version 1.6, I believe, and in 1.7, I think it was officially supported. Actually, no, 1.7 is the one version of Kubernetes that supports both third-party resources and custom resource definitions. I think they're interchangeable, and then after that, third-party resources has been dropped. So, okay, so let's go into, I'm confused. Maybe it was 1.6 that did the third-party resources and CRDs. It doesn't make a difference. The current version 1.9 doesn't support third-party resources, and now the default is custom resource definitions. Okay. So the next thing is the metadata. So this is your typical Kubernetes object metadata. You got name, you got namespace. So the name of my metadata is called fans.crd.emerald.io. So this is, I made a CRD called fans. And what this basically is an object to hold my favorite sports and sports teams. So for instance, for football, I'll put the Giants. For baseball, I'll put the Mets. And I'll be able to store that in an object. And when, basically, at the end of this, what I'll show you is when I go in and change stuff, I can show you how applications get notified in real time when things change. Okay, so the namespace is the namespace for your CRD. Yeah, so CRD is actually cut across namespaces, so this it's nice that I have this here, but okay. So we're going to make a namespace called test CRD, so I'll have to do that when I get out of here. So the spec is important. The spec is the group. So this is your API group. So when you go in through a browser or you go in through a Kubernetes client, this group is the API group. Typically, if you look at something else like API group for, let me see, I think the core one is like, give me 1 second, I'll look up the core one. Okay, core is, let's see, I think core is in the deployment moved to core recently, so I'm just pulling up the deployment. V1, so yeah, so go back to that. So the core is V1, so but this is an extension, so I get to make it whatever I want. This has to be a fully qualified domain name, so we call it crd.emerald.io. The version, usually it's V1, so I call it dev, just you know, just for now. It could be V1, it could be V2. This is meant for you know, multiple versions of your CRD. You could have different definitions in different versions. The scope is namespace, so this CRD is going to be able to be namespaced. Okay, names is important. Just some cool stuff here. So the plural is fans. So you'll see this when you operate through the kubectl command line tool. You'll be able to like say kubectl get fans in a certain namespace, and it'll give you all the fans. Or the next one is a singular. So when you say kubectl describe fan, you'll be picking a certain instance of a fan. The kind, typically this is the camel case, beginning with the first letter is uppercase of the singular. That's just kind of following, I guess, prescription from the Kubernetes documentation. The short names is a list of shorthand names for your Kubernetes object. So I could go at the command line and say kubectl describe fn, and it would translate fn into a fan, and I would go out and get the fan that I'm looking for. So something new that's in Kubernetes 1.9 is a validation. So we don't actually have validation right now because the cluster I'm going to run this against is version 1.8, but in 1.9 you can turn on, or actually it's turned on by default, is OpenAPI V3 Schema Enforcement. So you could go into your CRD here and you can say for certain properties, right, in my spec, in the properties football, the value has to be Giants. So I can say if somebody tried to switch that away from Giants, it would actually throw an exception saying that you know, it didn't pass validation. But that's enabled on version 1.9. It's not enabled in the version that I'm using right now. And the reason why that's important is because in the CRD, the spec section is kind of open freeform, which presents a whole bunch of challenges, right, for tools like Helm, and actually the Kubernetes engine itself. And when it goes to figure out what gets updated or take actions upon things getting updated, since this is free form, after the spec, and I'll show you that in a second, how it's free form, it's hard to make that decision. So it's a little bit difficult. And we've come across a couple of bugs with Helm with that, with CRDs. That have been fixed, but in the future I'm sure there'll be more bugs about this. But this Open API V3 Schema Enforcement I think is where they're going, with where the community is marching towards, away from maybe this freeform and having some kind of schema validation inside the spec section of the CRD. So okay, what we need to do first is we need to create this namespace, right? We're going to create the namespace because we have this test CRD namespace, right? So let's create a home to create our CRDs in. Okay, so let's create the namespace. It already exists. Okay, great. Let's do this. Let's actually start fresh. Let's delete our namespace because I know there's nothing in here. Let's delete that guy. Okay. I just want to make sure I start off with a clean slate because I was playing around with this yesterday, just in preparation for today. I want to make sure I start from scratch. So let's create a test CRD. And the reason I wanted to delete that was because any kind of stray CRDs that I have inside that namespace, by me deleting the namespace, it'll delete the CRDs. And it will delete all instances of the CRDs. Actually, I'm going to take a side and tell people about this. This is kind of like a caveat with CRDs. When you delete a namespace, and if your CRD definition is in that namespace, especially in a Helm chart too. So if you go into a Helm chart and you decide to remove a Helm chart, and that Helm chart had a CRD definition in it, if you have instances of your CRDs in other Helm charts, those will get deleted too. So you need to make a decision. You need to make a decision on whether you're going to keep all of your CRD instances bundled with that Helm chart that has your CRD definition, or you just realize that you can't get rid of the Helm chart that has a CRD definition. Somehow you got to manage that. So that's a word to the wise, how it is right now in Helm. If you go in and you delete a chart and it has a CRD definition in it, all of your CRD instances that are interspersed throughout other Helm charts will get deleted. You must be careful about that because it's a world of hurt if you delete that Helm chart with the CRD definition and your CRD instances are defined in other Helm charts. So just be careful about that. Okay, so let's go back to the terminal. Okay, so let's make our first, this is the definition. Okay, this is not the instance, this is the definition. So let's do kubectl apply. Okay, and we call it fan.yaml, right? Okay. Okay, so we have our custom resource definition. So basically we have a definition. It's a definition. That's all it is. There's nothing there. It's just a placeholder to go and get stuff. So let me show you a browser. Let me show you what it looks like from a browser. Let's switch to my browser. So I think this is the easiest way to see it. Okay. Okay, so this is what, this is my fans. You can see I ran this yesterday. So if I hit refresh, there shouldn't be anything in here. So let me hit reload. Okay, so you can see that there's nothing in here now. What it basically is you can get at your CRDs. This is issuing a GET request to the browser. Obviously, it's a GET. You go to you go to wherever your cluster is, the API service to your cluster. This is a private load balancer for all those people out there who are going to try to hack into where our Kubernetes cluster is, the API servers are. You can't get to it. This is a private load balancer. You can't get to it. So this is APIs. This is the pattern. You say APIs, and this is the group that we defined in our CRD, crd.emerald.io. This is the version. I called it dev. And this is, I could say, give me all the fans. And you can see that there's nothing here. Just see the items are empty. And I say, it translated into a list because I said fans. I guess if I go here and I say, just give me all dev, you can see this is my resource list underneath the group. You can see I have fans. It's singular is fan. It's namespace. It's a fan. Here's all the verbs you can do against it. And this is the cool one, watch. I'm going to show you guys how to do this. Watch is super cool. Super cool. Okay, so let's go back to my terminal, and we're gonna make our first first instance here, right? So let's make a fan. The YAML. Okay, so what you do is to make your YAML, you have to specify your API version. So it's CRD to emerald.io, and the version is dev. Typically it would be V1 or V2 or something like that, but I just made it dev. What kind is it? It's a fan. So this is how it ties into the kind that's in your CRD definition. It's a fan. The metadata, so here it's the name. I'm saying this is a new fan, and this is in the namespace test CRD, and the spec. So this is kind of free form. You got football, Giants, you got baseball, Mets. Okay, so I can type in any kind of valid YAML I wanted to on the bottom there. Just for simplicity's sake, I just picked my favorite football team and my favorite baseball team. And what I'm going to do now is I'm going to create it. So how do you create it? You just do kubectl apply, give the name of your file that you made, make fan. Obviously this can be automated. This is really simple, very simple. Okay. Okay, and there our fan is created, right? Awesome. So let's go back to, well, actually let's stay here. Let's do kubectl. Now you can do gets. So you give me the fans. Give me all the fans. Get fans across all the namespaces, right? Okay, and then you see there's our new fan. He was made 22 seconds ago in the test CRD namespace. So let's see what he is. Let's see. Describe the fan. Test CRD or new fan rather. In the namespace test CRD. And here's our fan. Here's some metadata about the fan. You have a version, which is actually kind of important. I'm going to show you that in a second. So here's our data. Here's our spec data. Here's the payload of what we're interested in right here. We're interested in this. We're interested in the version. And we're interested in the API version here and the kind here. Okay. So let's look at the shorthand that we had before. We defined that shorthand, and this should work too. So if we do describe fn, new fan, and -n test CRD. Remember that shorthand was fn. This should translate to fan. Let's see, fans, new GAN. Should be new fan. Okay, so you see that shorthand works. Okay, so let's make a change. Let's actually do this interesting tidbit now. So you see that you can get at it through the command line. Let's show you through the browser. Okay, back to the browser. So these are all the, okay, give me the fans. Okay, so now you can see, hey, it comes back. So there's my fan with Giants, baseball is Mets. Here's the definition. I have one fan inside my CRD, right? Really simple, super simple. It's meant to prove a point. You can do a lot with this, and I'll show you in a second. So let's get into the super cool part. Okay, so let's write something called a controller. I'm using a Python library to do this, the Kubernetes Python library. Let's go back to our command line. Okay. Let's look at my script here. It's really a simple script. Okay. So you can see from the Kubernetes library, we're going to import client config and watch. This config load kube config, you need to do this no matter what. So it's going to load your current kube config to figure out how to talk to the cluster, whether you're talking to Minikube or whether you're talking to your cluster or cluster in a different environment. I'm going to use the default, so I'm going to talk to our dev cluster that I have set up. Okay, this custom objects API. So this is this is the CRDs. This is the way to get at the CRDs. You got to say Kubernetes client dot custom objects API. Now we'll give you a client into the CRDs. I have this like watch thing to escape out after it gets 10 updates. Okay, and what we're going to do, so from the Kubernetes library, we get this watch library, and we're going to call watch. And so this is going to give us a watch. and we're going to say, okay, stream in the watch. What are we going to watch for? We're going to watch for the client's going to be the CRDs client, and we're going to list the cluster custom objects. So what this is going to do is going to go through and it's going to list all the events that happen on the cluster CRD objects. So the cluster wide. There's also a list of namespace custom objects, which can limit it to a namespace. But I'm using the cluster wide one, so you could use either one. I guess in my case I could have used the namespace one because I put everything into one namespace. Okay. The next parameter is the group that you want to listen for. This is the API group. The next one is the version of the API group you want to listen for. So that's the dev version of the API group. Okay, and then what do you want to listen for? I want to listen for fans. Give me some fans. Give me events that happen with fans. Pretty is true is the output of the JSON. And the resource version is important, so I'm going to leave it empty. So what this means is that when you say resource version, you say only stream events that occur after this resource version. I left it blank, so it's going to give me all the events that happen for everything from the beginning of time for the resources. You may not want that. You may say like, oh, hey, I remembered everything up to a certain resource version, so don't replay everything. So this is how you would do it. You would say, okay, I remember where I left off, and give me the resource version starting with this resource version. But for simplicity, what I'm going to do is I'm going to get everything, because there's not a lot of events that have just occurred. I created one. I created a CRD, and that's it. So I should only get one event. But in a real-world example, you probably want to utilize this resource version to not keep replaying the same events over and over again. Okay, and the reason why this is powered by etcd. Etcd keeps a log file of events that get stored in the etcd cluster. So you have etcd cluster of 3 to 5. Usually it's an odd number, and you're allowed to. You're able to, I guess, survive. Let's see, n divided by 2 plus 1, or n divided by 2 minus 1, n divided by 2 minus 1, I think, members of your cluster going down. So if you have a 3-member cluster, 1 can go down, you can survive that. If you have a 5-member cluster, you can survive, let's see, 2 going down, right? Yeah. So if you have a 7-member cluster, you can survive 3 going down. Yeah, that's right. Because you gotta have a majority. Majority have to be up. So with 3, your majority is 2. With 5, your majority is 3. With 7, your majority is 4. So it's not n minus 2 minus 1. That's not incorrect. It's the majority. The minority you're allowed to withstand going down. Okay. So yeah. So I guess that would be n minus 2 minus 1. Okay. So I am correct. All right. So and then this request timeout is 60 seconds. Okay, and real quickly, back again about etcd. So there's a log file that gets replicated through the REF protocol between the etcd clusters. So they're able to keep track of events, and they're all synced up on that log file from the beginning of time. And that's where this resource version comes in, because I guess that comes into play when it goes and it figures out what events to stream to the clients. Okay, so and all we're doing here is printing out the events when they go through. And there's a counter here every time it gets an event in decrements, and I guess when it hits 10, then it will stop. Okay, so let's spin it up. Okay, so this is Python 3. So I'm going to run Python 3, watch CRD. Okay. Okay, so you can see here's the event added. It is... somebody added a event here. I get told about it, and it's my CRD. So let's do this. Let's go change it. Let's go change it. So let's cool. Okay. All right. Look at this. I already had it up over here. So let's edit the fans. Let's edit this guy, the new fan. Let's edit him. Let's change it up, and you can see the data, the notification in real time of things getting updated. Okay. Let's make it hockey Rangers. Okay. Okay, so it's updated. Let's go back over here, and bang, look at that, modified. So we get notified real time in my application that a change has happened to my CRD. This is obviously super powerful. This is really powerful stuff. If you work in distributed computing, or if you have a website that's distributed geographically, if you have data that needs to be geographically distributed, this is just a super thing. It's super cool. So you can see that I get notified whenever a change happens to this. So let's actually delete it now. Kubectl. Let me delete it. Delete fans in the test CRD namespace. Which one am I going to delete? The new fan, right? I'm going to delete new fan. Okay, so he's gone. So over here, bang, you get notified, hey, is this thing got deleted? So you can see the tie-in here. So this is my application on the side that, see, I wrote a quick, like 7 or 8 line Python script to show to you the power of this thing is that you can now react in real time to your data changing on you. So this is actually what I was talking before. This is what Dex does. So Dex stores its CRDs inside the Kubernetes API, and then there's controllers out there listening for these changes. So this is a really cool thing, and it's actually a big paradigm shift. The paradigm shift is traditionally you have an RDBMS where your data is stored and it sits there, and it gets updated, and you have triggers and whatnot that may have to call out the things to let them know that events occurred and take action. But this is a new way to do it. Typically, like your RDBMS, your data gets updated and nobody knows about it, right? In this case, and this is the whole system that powers Kubernetes, this is what makes it tick. Because beyond CRDs, there's also services, there's config maps, there's deployments. You have all those core things, and this is what it's built on, is that whenever there's changes to stuff, there's applications out there listening for the changes and taking action. Like for instance, if I decide to add a new pod in my deployment, Kubernetes itself is listening for changes to that, and we'll go into the service and add that pod behind the service when it's available. That's how it does service discovery. It's all based upon this watch kind of paradigm, where your infrastructure is listening for changes. It's not being told what to do. It's listening for changes and taking action. So this is how the automation occurs within Kubernetes. It's all powered by etcd, and that's how it all works. That's how it all ties together. So if you can understand this with the CRDs, then you understand how the whole system works for Kubernetes, because it's all predicated upon the watch. Everything is happening in real time based on the watch API. So we have some examples on our side. We watch for things like, I've had to write custom controllers in Kubernetes. We do things like, I guess in the early days there was no metrics for jobs, and we had to cron jobs, that is, schedule jobs, and I had to go in and write watchers and controllers for cron jobs to take actions when either cron jobs weren't running or when they were running. I've had to do that. So another one is if you look at Kelsey Hightower's conf.d, that actually does a polling mechanism, and that could actually be updated to do a watch. You could actually just watch for new resources of type config map, and then when it gets fed in, it can also go and evaluate your config maps for you using the template engine inside conf.d. Where it actually gets used recently is ingresses. So when you create ingresses, the STO controller or the Nginx controller, just depending upon what you're using for your ingress controller, will be listening for ingresses and taking action in real time, reconfiguring Nginx or reconfiguring Istio based upon ingresses that you define. So just by the fact of you going up there and publishing an ingress, the controllers are listening for changes, ingresses, either updates, removes, deletes, modifies, whatever, and it will go in and it'll reconfigure Nginx for you, reconfigure Istio for you in real time, automatically. So this is the power of the watch paradigm and CRDs. So CRDs just take it to a whole new level. For me, this is the big definition. The big differentiator between Kubernetes and anything else is the ability to extend that core API functionality out to your own objects. So I can write like my fans object if I wanted to. That's a really silly example, but you could figure out many different business use cases for this, including authorization tokens. I think that's the most obvious one is anything where you need to immediately tell things out there that something has changed. For me, that would be like either like a session or a token or something like that. Stuff that has to do with security and identity. That's really where you get a big win with this stuff. Other than that, you could use the CRDs to store your application data if you wanted to. I don't know if you want to mix it in with everything else that Kubernetes is doing, because you're going to have to compete for resources with the etcd cluster with all the other stuff that's on Kubernetes. So if you have something where you need to do like thousands of requests per second, I wouldn't recommend you use the CRD approach, but you could if you have something that doesn't get updated that often. Most use cases don't require thousands of writes per second, but most of your use cases require, a couple of requests per second. And then maybe CRDs are a good option for you for storing your application data. As opposed to inside an RDBMS, you can store them inside the Kubernetes API. So actually the paradigm shift here is moving away from putting your data inside a traditional database RDBMS store and putting them behind an API. And you don't care how it's stored, right? You just have an API to get it. So that model is really powerful, and I think it's going to take off in, if not this year, maybe the year after, because I think we're really out in front of the curve with this stuff. I think this is really revolutionary for some people to see this, especially when applications or controllers get notified in real time of your application changing on you. It's a really powerful thing. If not this year, probably be next year. Especially with etcd v3, with the ability to watch for pretty much an unlimited amount of changes to your data through one connection. That is super powerful. Okay, so let me go back to I'm going to go back to here and make sure that there's no chat questions. I don't think so. I got some people out there watching. Cool, awesome. Well, this hopefully I got my point across to you guys. I want to talk about CRDs. So I went through creating a CRD definition. I went through creating an instance of the CRD. I went through deleting the CRD. I showed you guys how to create a simple client that goes through and listens for changes to a CRD. I showed you how to get to the CRDs through the browser, through the API manager for your cluster. API manager is running on each one of your masters, right? So if you have 3 masters, you have 3 API managers, and they can all service the same requests. Usually there's a load balancer in front of them that round robins between your 3 masters. In my case, in this demonstration, I showed you a URL that points to a private load balancer, so don't try to get to it at home if you look at this, because you're not going to be able to get to it because it's not a public-facing load balancer. You have to be within my corporate VPN to get to it. So it was just a demonstration purposes only. And yeah, I think I went into a little tirade about the power of this and where I see the future of this. It really is a world where your database side of things is getting into the DevOps kind of world of automation and trying to automate everything as much as possible. So what does that mean for RDBMSs in the future? I think there's still a place for them. But I think when it comes to microservices, maybe you don't need a full-blown RDBMS. Maybe having things behind the API manager and storing your objects as CRDs is enough. Why do you need a full-blown RDBMS for that? Because you're getting replication with the etcd cluster, you're getting out-of-the-box API access, you're getting RBAC that comes along with it, with the security mechanism for Kubernetes. So it just simplifies, I guess, that side of it. When your application needs to persist state. Obviously, there's a lot of use cases where you might actually need to keep using RDBMSs, but it'll be interesting in the future, right? In this kind of hybrid world where maybe some applications store their data in CRDs. The only way to get to them is through an API, which is like the holy grail, right? Because you don't want. It would be awesome if everything had the same front door to get to the data. Okay, so that's it. I think I touched upon etcd V3 versus V2 and why I think you should upgrade to V3 versus V2. And other than that, I will get back to everybody with what my topic is next week. So this one was a quick one, but a very powerful one. I think that I needed to show everybody the previous week's services, log aggregation, and how I went through all the basics of Kubernetes to actually bring to you, this is an advanced topic that shows you the power of Kubernetes. And this is the one differentiator for me between Kubernetes and Swarm and Mesos and all that stuff is this ability to extend the API and store your own CRDs. I don't know, so I know Amazon has the AKS tool. I don't know if they allow you to do CRDs. If they do, I'm not quite sure. GCE, I'm not quite sure either because we run our own private cluster. Because we're using like CRDs and stuff like that. And one other thing is, I know Federation, if you're trying to federate clusters, the Federation, they're moving away from Federation, the community that is, towards something else. And I think a big reason for that is because of CRDs, because CRDs weren't supported through replicating federated clusters. So now they're moving towards like a multi-cluster kind of installation. It's been renamed, and they're going to figure out, hopefully they're going to figure out being able to have CRDs across multiple clusters. So that's it. Everybody have a good weekend. I'll set something up shortly, and have a good day, everybody. Talk to you later. Ciao.